Okay, we have this equation, and we see that of course x is in the exponent, so we can't deal with it as an algebraic quantity unless somehow we get the x out of that exponent. Okay. Now, if we have this form, we can change it to this form. If we have this form, we can change it to this form, and we know that. But it's not in either form. It's kind of in a form like this, but it's got that 5 in front of it. Okay, so it's got to be to something equal to something else, but you got a 5. Okay, what are you going to do with that? Well, we can divide both sides by 5, and now it is in this form. Now that it's in this form, we can convert it to logarithmic form. We get log base 7 of 4 equals 3x minus 9. And I'm not going to re-explain that. We've explained that in a lot of detail. And people are actually doing pretty well with that. So that, let's just switch sides so to get the x on the left, which is where we usually like to see it. We could solve it with x on the right, that wouldn't be a problem. But we switch it just to make it look a little more familiar. And we see that, well, let's see. Log base 7 of 4 is just a number. You can punch your calculator if you punch the right buttons and find out what a decimal equivalent of log base 7 of 4 is. A decimal approximation, not equivalent. But we're going to do an exact solution, so we're not going to do that. But we do understand that this is just a number. Even if we don't know what the number is, this is just a number. So we got 3x minus 9 equals some number. How are we going to solve for x? Well, let's add 9 to both sides, and we get then 3x equals log base 7 of 4 plus 9. Then let's divide both sides by 3 or multiply both sides by 1/3, and we get x equals log base 7 of 4 plus 9, all that divided by 3. Now if we want to, that's a perfectly good exact solution. If we want to punch it into the calculator, we have to express log base 7 of 4 as log 4 divided by log 7. So this is actually not a simple fraction, and officially we're supposed to reduce any fraction to a simple fraction. Just put that line in there to make sure we didn't see the 3 as an exponent and the 9. It's okay, so we're really supposed to put that in the form of a simple fraction. If you're going to punch it into the calculator, this form works at least as well as any other, so I'm just going to leave it in this form. This is your exact solution. I would say that this is acceptable, but this is really, yeah, either way, okay. All right. Now, here I have a list of the problems that we're going to work through. That's the first one. Okay, the second one is here. 1/3 log base 9, etc., etc. You can read it as well as I can. Is this, first of all, the x that we're looking for is inside of the log. So for the x that we're looking for is part of an exponent or part of the argument of the log function. We're going to have to do a conversion using one of these rules. This is not quite in either of these forms. If the 1/3 wasn't there, it would be. So if we multiply both sides by 3, we'll get rid of that 1/3. We'll have log base 9 of 3x plus 5 equals 3 times 3, which is 9. Follows then, we have it in this form. We can translate it to this form. And this form of this equation is 3x plus 5 equals 9 to the 9th. So that 3x equals 9 to the 9th minus 5, and x is 9 to the 9th minus 5 over 3. And then I say equals, etc. You can raise 9 to the 9th, it's 300 and some million, I think. Well, or you can punch it into a calculator. Or you can just leave it in this form, as far as I'm concerned right now. Now, there's another thing that we could have done over here, okay? we know, never mind, there's another thing we can do over here. Okay, that's a different problem. Okay, and some people did this and that was quite good. We know from some of the properties of logarithms that a times the log of m is the log of m raised to the a power. So we can write this as log base 9 of 3x plus 5 raised to the 1/3 power. Just that's like an n log m. Gives you log of m to the n. And of course those are properties that you get used to by working with them. So we would get this, and now this is in a form that can be converted to exponential form. We get 3x plus 5 to the 1/3 equals 9 to the 3rd. Now how do we solve this equation? Well, we raise both sides to the 3rd power, because when you raise a power to a power, you get the product of the powers. So that 3x plus 5 to the 1/3 raised to the 3rd just gives you 3x plus 5, because that's 3x plus 5 to the 1/3 times 3, which is 3x plus 5 to the 1, which is just 3x plus 5. So we get 3x plus 5 equals 9 to the 9th, because we have 9 to the 3rd here, which is 9 to the 9th. Again, we multiply exponents here as well. Okay, and this equation is the same as this one now. So this would just be another strategy using a different property of logarithms. Couple more problems. 2 times the natural log of 5 over x equals 10. How do we solve that? Well, first of all, we recognize that the natural log means log base e. So that's one thing you just need to be aware of. Now, we've talked about that a couple of times. That's what the natural log means. And you really want a log with a base so that you can convert it. Okay, well, we can't convert yet. We have to divide both sides by 2 to get log e of 5 over x equals 5. Now we can convert. E to the 5th equals 5 over x, using our rules, which we practice enough that we get them straight and we remember how they work. Okay? So we get e to the 5th equals 5 over x. If we then, the x that we're looking for is in the denominator. How do we get the x out of the denominator? Well, anytime we have denominators in the equation, we multiply by a common denominator. Okay? So if we multiply both sides by x, as we do here, x times 5 over x, well, x divided by x is just 1, and 1 times 5 is 5, so we get 5. And then we have x times e to the 5th equals 5. Well, we divide both sides by e to the 5th. X times e to the 5th over e to the 5th equals 5 over e to the 5th. So that x equals 5 divided by e to the 5th. And this is an exact solution, which we can approximate if we wish using a calculator. Okay. You're going to get something like 0.03 something, I believe. But, approximate it yourself. Okay, so fairly straightforward if you just keep your wits about you and use the common techniques that are used in solving equations. Adding, same thing to both sides, subtracting, multiplying, dividing. Taking powers of both sides. Okay, another one, e to the negative 3x plus 2 over 4 equals 9. Well, if we multiply both sides by 4, we get this, which is now in the form that can be converted to logarithmic form. So we get log base e, because this is e to a power, e is your base, it'll be the base of your log, raised to the 36, log base e of 36 equals the exponent negative 3x plus 2. The rest of the solution is very straightforward. First of all, though, we write log base e of 36, you don't know what the number e is. It's an irrational number. You can't write it down exactly. But remember that log base e is a natural log, and you have a natural log key on your calculator in case you need to evaluate this. So it's going to be very convenient to use the natural log here. Okay? So, instead of log base e 36, we write natural log 36. Then subtract 2. First of all, switch sides so the x is over here. Then subtract 2 from both sides so that we're going to have just a negative 3x here and the natural log of 36 minus 2 over here. Then we're going to divide by both sides by negative 3. I didn't write down every detail of that, but you should. X is natural log of 36 minus 2, all divided by negative 3. Now, dividing by negative 3 is the same as dividing by 3 and then taking the negative of everything that we have. And this, in fact, simplifies to this, which is the best form. I would probably penalize this form just a little bit. Either of these forms I would probably accept. Okay. Those are the 4 equations that we looked at. And then, for a little more practice with exponents, we solved a couple of questions involving exponents. Just checking the time of the camera, and I think I can get this in the same video, okay? So, let's take the equation 5x to the negative 2/3 equals 12. Now, we don't have to change this to exponential form because the x that we're trying to solve for is not in the exponent. We don't need to change this to logarithmic form. It's kind of, there's an exponent involved, but x is not part of the exponent. So this is not an exponential expression. It's a power of x. Okay, so if we divide both sides by 5, we get x to the negative 2/3 equals 12/5. If we then take the negative 3/2 power of x to the negative 2/3, we get x to the negative 2/3 times negative 3/2. So just to write that down, x to the negative 2/3 times negative 3/2 equals x to what? That's going to be 6/6, which is x to the 1, which is just x. So that x to the negative 2/3 to the negative 3/2 is just x. And that'll be equal to 12/5 to the negative 3/2, since we need to take both sides of this equation to the negative 3/2. And x is then 12/5 raised to the negative 3/2, which you can easily punch into your calculator. Similarly, x to the 4/5 equals 17. Well, I'm going to do this in a separate video because I will explain every step and say a couple more things.